So myself Dr. CS Ahir. So let's start this third chapter or the last chapter, Ionic Equilibria. So in second chapter we complete this chemical equilibrium. In that we have studied the dissociation of chemical compounds in solid, liquid and gaseous state. In this chapter we shall study the concept of ionic equilibria involving the dissociation or ionization of weak electrolyte such as weak acid, weak bases, particularly in aqueous solution. pH scale, common ion effect, hydrolytic ionization of salt, ionization of sparingly soluble salt in aqueous solution. So this type of concept we have studied in details in this chapter. So strong, moderate and weak electrolyte. Before that we consider this electrolyte. What is electrolyte and non-electrolyte? So on the basis of ability of substance to conduct electricity in aqueous solution, the substances are classified as electrolyte and non-electrolyte. So what is electrolyte? Substance which conduct electricity in aqueous solution due to presence of ion are called as electrolytes. For example, acid, bases and salt. Non-electrolyte, substance which do not conduct electricity in aqueous solution due to presence of, not in this case due to absence of ion, are called as a non-electrolyte. For example, glucose, sucrose, glycerol, urea, hydrocarbon, these are the examples of non-electrolyte. See, when we add NaCl in water, it forms salt solution. When we add sugar in water, it forms sugar solution. Both salt and sugar are soluble in water. But this salt solution conduct electricity, and thus this salt NaCl act as a electrolyte. But the sugar solution do not conduct electricity, and thus the sugar solution act as a, or the sugar, sucrose, glucose act as a non-electrolyte. So now we consider this electrolyte which aqueous solution conduct electricity. These electrolytes are classified into strong, moderate and weak electrolytes. So what is strong electrolyte? The electrolyte when dissolved in water ionizes or dissociated almost completely. So near about 100% ionization. Such type of electrolyte is called as a strong electrolyte. So for example, most soluble salts, strong acid like sulfuric acid, nitric acid, hydrochloric acid, HBr, and strong bases like NaOH, KOH, etc. On the other hand, we have this weak electrolyte. The electrolyte when dissolved in water ionizes or dissociated only partially. When we consider the extent, so it is only 5% of total amount. When 5% of electrolyte is ionized, that type of electrolyte we call it as a weak electrolyte. For example, weak acid, that is acetic acid, carbonic acid, weak bases like ammonia, ammonium hydroxide. So in between these two we have the situation that is a moderate electrolyte. The electrolyte which dissolve in water ionizes or dissociated to a 50%, near about 50% ionization is called as a moderate electrolyte. So they may be called as a moderate electrolyte. For example, at optimum condition of concentration and temperature, this strong electrolyte act as a moderate electrolyte, or it behave as a moderate electrolyte at optimum condition of concentration and temperature. At the time it dissociated near about 50%, that is a half quantity is ionizes. So we have three type of electrolytes. Now we consider this degree of ionization. When we consider this electrolyte dissociated to form ions, for that we consider this degree of ionization. So according to Arrhenius theory of ionization, the molecule of electrolyte when dissolved in aqueous solution split into positive and negative charge particle. We called it as a cation and anion respectively. This splitting phenomena of electrolyte in aqueous solution is called as a dissociation or ionization of that electrolyte. So this dissociation ionization is the phenomenon to produce cation and anion. Consider this electrolyte example, NaCl. This NaCl solid added in water at equilibrium it form Na plus and Cl minus. So it produces cation and anion. When we add magnesium chloride in water, it produces magnesium 2 plus and Cl minus twice. When we add acetic acid in water, it produces acetate ion and H plus, that is proton, in aqueous medium. So this ion produced by ionization or dissociation of electrolyte again combined to give undissociated electrolyte molecule called as a ionic equilibria. So this reaction we write in equilibrium form. So what is ionic equilibria? This ion in water or aqueous solution to produce ions, and this ion combine back to form a undissociated electrolytes. So this magnesium 2 plus combined with 2Cl minus in reverse direction to form a magnesium chloride. So this back reaction is also happen, and this situation, this equilibrium situation is called as a ionic equilibria, similar to that of chemical equilibria. So this is the ionic reaction, so we call this chemical equilibria as a ionic equilibria. So this ionic equilibria is production of ion and ion combined to form a undissociated electrolyte. The fraction of total number of molecule of a electrolyte that split or ionize into cation anion is called as a degree of ionization or degree of dissociation. So it is a fraction of total number of molecule of electrolyte that split ionize to a cation and anion is called as a degree of ionization or degree of dissociation. So see, this degree of dissociation is denoted by Greek letter alpha. And this degree of dissociation alpha is calculated by using formula number of molecule ionized or dissociated upon or divided by total number of molecules. So this is the fraction. Number of molecule ionized or dissociated upon total number of molecules. The degree of ionization generally increase with the dilution. When we add more and more solvent, this degree of ionization goes on increasing. That means they produce maximum or more number of ions, and its value become maximum at infinite dilution. So we have this infinite dilution, large amount of solvent is added at that time, this degree of ionization is maximum. So now we consider these factors affecting on degree of ionization. So degree of ionization of electrolyte in solution depends on following factors. So first is nature of electrolyte. So when we have weak electrolyte, just now we classified electrolyte as a weak, moderate and strong. When we have weak electrolyte, they are partially ionized and thus it has low degree of ionization. On the other hand, strong electrolytes are almost completely ionized, thus it has high degree of ionization. When you have this ionic electrolyte, these ionic electrolytes are having more degree of ionization. Second factor is nature of solvent. Solvent with high dielectric constant and high solution power like water ionize the electrolyte to a greater extent than the solvent with low dielectric constant like benzene. So high dielectric constant, high solution means more polar solvent shows more ionization, and this benzene, it is dielectric constant is less, so it is non-polar solvent shows less degree of ionization. Third factor is the concentration of electrolyte. This ionization or dissociation of electrolyte increases with increase in dilution. So when we decrease the concentration, we increase the dilution, at the time ionization or dissociation increases. And this increase in dilution in solution, the ion form in the solution move apart from each other and attractive and repulsive forces become negligible and dissociation of ion increases. So by increasing dilution by addition of solvent, this attractive repulsive forces between ion decreases and degree of ionization increases. Fourth factor is the temperature. Thus this ionization or dissociation is a endothermic process, and hence degree of dissociation or ionization increase with increase in temperature. So this ionization process increase by increasing temperature. And the last is presence of common ion. Due to common ion effect, that is presence of common ion tend to reduce the degree of ionization. So this factor reduce the degree of ionization. For example, this ionization of ammonium hydroxide, weak base, decrease in presence of ammonium chloride. Ionization constant of weak acid. So consider an ionization of weak acid, general acid, as a HA in aqueous solution at equilibrium. So we write this general reaction. HA is a weak acid added in water. At equilibrium it produces hydronium ion plus anion. So this HA dissociated, it produces H plus, which get combined with water to form hydronium ion, and the same minus is produced. So it produces cation anion. Consider according to equilibrium law, we have equilibrium constant at K, capital K, is equal to concentration of hydronium ion into concentration of A minus upon concentration of undissociated weak acid into concentration of water molecule. Here this square bracket represents the molar concentration, that is a moles per liter of each species. It may be molecular or ion. Here in dilute solution, this concentration of water is very large, excess, and we consider as a constant as small k. And this hydronium ion is a concentration of actually proton concentration, H plus ion concentration. So we substitute water concentration by small k and hydronium ion concentration by H plus. So we have the equation, this hydronium ion is H plus, this water concentration we consider as a small k. So we collect this constant term on one side, that is capital K into small k, this remaining part. This capital K and small k both are constant. For this both constant, we write this new constant, that is Ka. So what is this Ka? It is a ionization constant of weak acid, A. A represent acid. So it is ionization constant of weak acid and is equal to the concentration of H plus ion into concentration of anion upon concentration of undissociated weak acid. See, hence this ionization constant of weak acid Ka is the characteristic constant and is equal to product of molar concentration of hydronium ion, hydrogen ion, and anion divided by the molar concentration of undissociated acid. So this is the undissociated acid HA. So its concentration. So this ratio is called as a ionization constant of weak acid. Ka varies only with temperature of ionic equilibrium reaction. So it depends upon temperature. K is a equilibrium constant of weak acid. It is called as the ionization constant of weak acid. So this ionization constant of weak acid Ka is also related to degree of ionization alpha and initial molar concentration C of weak acid. Consider the ionization of weak acid, acetic acid in aqueous solution at equilibrium. So we have this equilibrium reaction for acetic acid. So this acetic acid at equilibrium produce acetate ion plus proton or H plus. So here water is excess. We consider this reaction in aqueous solution. So initial molar concentration, initially there is only acetic acid, there is no ionization, so we have this zero concentration. At concentration at equilibrium, when this reaction reaches equilibrium, at that time this acetic acid dissociates to form acetate ion and H plus. Suppose C is a initial concentration. Alpha is degree of ionization of this acid, acidic acid. So this acetate ion produces a C into alpha. Proton produces into C into alpha. Same molar concentration. So what is the remaining acidic acid? So it is decreases by C alpha. So we have the remaining concentration of acidic acid is a C minus C alpha. So C minus C alpha. From these two terms, when we take C common, so what is the remaining term? 1 minus alpha. So this is the concentration of acidic acid at equilibrium. Initially is C concentration. Now it has a C common 1 minus alpha in bracket. So C into bracket 1 minus alpha. This is the equilibrium concentration of acidic acid at equilibrium. Where at equilibrium unionized acetic acid is equal to C into bracket 1 minus alpha, and equilibrium concentration of acetate ion is equal with proton concentration or H plus concentration, both are same, is equal to C alpha. So according to equilibrium law, we get Ka ionization constant of weak acid is equal to the product of concentration of acetate ion into product of H plus ion concentration divided by concentration of undissociated acidic acid at equilibrium. So we put these values, substituting the values of concentration at equilibrium, we get this Ka is equal to C alpha into C alpha divided by C into bracket 1 minus alpha. So C alpha into C alpha is this, it is equal to the C alpha square upon C into bracket 1 minus alpha. So this C square is cancelled with C. See, there is no C. C alpha square upon 1 minus alpha. This C is cancelled with C square. C is cancelled with C square. So what is the final equation? So there is a mistake. This C is not there. The final equation is K is equal to C alpha square upon 1 minus alpha. C alpha square upon 1 minus alpha. This C is cancelled with C square. So one C is remaining, C alpha square upon 1 minus alpha. The above equation, this relation between the ionization constant Ka of weak acid to the degree of ionization alpha and initial molar concentration C of weak acid. So ionization constant of weak bases. So similar to the acid, we have this weak base. Consider an ionization of weak acid, BOH. This BOH we consider as a weak acid in an aqueous solution at equilibrium. So this weak acid dissociated at B plus and OH minus. According to equilibrium law, we have this equilibrium constant at Kb is equal to concentration of B plus into concentration of OH minus divided by undissociated base concentration, that is concentration of BOH, where the square bracket represents the molar concentration, that is moles per liter of each species. Hence this ionization constant of weak acid Kb is the characteristics constant and equal to product of molar concentration of cation and hydroxyl ion, divided by molar concentration of undissociated base. This Kb varies only with temperature of ionic equilibrium reaction. So this much part we studied today's lecture. Thank you.